Добрый день, дорогие коллеги, уважаемые члены диссертационного совета. Hello, dear colleagues. Today is the defense of the dissertation by Bukenov, Bauyrzhan Umurbekovich, on the topic development of analytical methods for determination on asymmetrical dimethyl hydrazine transformation products in air specialty D05 301 chemistry. Scientific supervisors Bulat Kinesov, PhD, professor of the Department of Analytical Colloid Chemistry and Technology of Rare Elements, Al-Farabi Kazakh National University, and Dmitry Kosikov, PhD, docent, director of the Core Facilities Antarctica of the NASAN Arctic Federal University, named after Lomonosov, member of the Scientific Council on Analytical Chemistry of the Russian. The dissertation was performed at the Department of Analytical Colloid Chemistry and Technology of Rare Elements of the Al-Farabi Kazakh National University. Official reviewers Wujun Lee, PhD, professor at Nazarbayev University, Astana, Kazakhstan, and Sholokhova Anastasia Yurievna, candidate of chemical sciences, leading researchers, head of the Laboratory of Smart Methods of Chemical Analysis from Frumkin Institute of Physical Chemistry and Electrochemistry, Russian Academy of Sciences. Temporary members of the Dissertation Council, Veronica Pino, PhD, full professor in chemistry, University of La Laguna, Spain. Atilio Nacarato, PhD, professor, Doctor University della Calabria, Associated Professor, Italy, and Javier Hernandez Borges, PhD, Professor, University of La Laguna, Spain. And the floor is given to the scientific secretary, Professor Uralbekov Bulat, to present the documents available in the applicant's personal file.
Yeah, thank you, Chairperson, Chairwoman. Let me introduce the documents we have in our council and the information about candidate. The name of the candidate, Bukenov Bauyrzhan, born in 1994. First, his undergraduate studies at Al-Farabi Kazakh National University from 2012 to 2016 at Faculty of Chemistry and Chemical Technology, majoring the chemical technology of organic substances. In 2016, he entered a master program in chemistry at Kazakh National University, and which successfully completed in 1918. From September 9, which successfully completed in 2018. From September 2019 to May 2022, he pursued his doctoral studies in chemistry at the same faculty. The topic of his dissertation and scientific advisor approved by Academic Council of Kazakh National University, Al-Farabi Kazakh National University on October 23, 2019. The personal files of Bukenov Bauyrzhan contains copies of his bachelor and master diplomas, list of his publications, the recommendation letters from advisors, both local and abroad, foreign, and the protocol of extended meeting at the department, and all the required documents in accordance with regulations of the Committee for Quality Assurance in Science Education of the Republic of the Kazakhstan. As a part of his thesis, the candidate published 3 peer-reviewed papers, including one paper in Q1 journal, a journal microchemical journal, and 2 papers in Q2 ranked journals of separation science. On June 2 and 2025, Bukenov Bauyrzhan's dissertations dissertation was discussed at the extended meeting of Department of Analytical Colloidal Chemistry and Technology of Rare Elements at Faculty of Chemistry and Chemical Technology. And there were 43 participants. The first reviewer, Professor Minazheva, professor at the mentioned department, and the second reviewer, Gulzia Mengeldievna Selkhanova, Doctor of Chemical Science, Professor at the Department of Physical Chemistry, Catalysis and Petrochemistry. They both gave positive comments and recommended the thesis of the candidate to defense, and all the questions and comments raised by reviewers were received by reviewers, which received comprehensively answered by the candidate, and as a result, the academic seminar, recommended the thesis for defense. An expert from protocol number 1, dated June 2nd, 2025, was approved by Vice Rector for Research and Innovation, by Ibrahimov Marghulan Kasenovich. And finally, on October 2nd and 8th this year, by protocol number 43 and 44, our dissertation council scheduled or approved the defense date, official reviewers, and the temporary members of the dissertation council. So that's all. Which and if you have questions, I am ready to answer.
Thank you. Dear colleagues and members of dissertation council, do you have any questions for the scientific secretary or the PhD candidate?
Здесь докторантуру закончить.
No. Okay. The next, the floor is given to the applicant to present the content of the dissertation, and you have 20 minutes. Yes.
Do you see the presentation? Sorry. Demonstration.
Yeah.
Okay, thanks.
Okay.
So, topic of the dissertation is development of analytical method. Greetings to everyone. First of all, sorry. The topic of the dissertation is development of analytical methods for determination of transformation products of unsymmetrical dimethylhydrazine in air. So, unsymmetrical dimethylhydrazine is a highly toxic rocket fuel component widely used in rocket space activities. In Kazakhstan, it's mainly used in Proton M launch vehicles. As a result of these activities, large amounts of the fuel are released into the environment during fall of first stages and during the accidents. Once EDMH enters the environment, it reacts rapidly with oxygen and components of soil and water, forming numerous nitrogen-containing compounds, which are potentially toxic, can be toxic to the human health. These compounds can persist for years, continuously volatilize from contaminated soil into the atmosphere. Therefore, even long after a launch, the surrounding air can contain measurable amounts of transformation products. At the present, national guidelines exist only for NDMA and DMF, which have defined maximum permissible concentrations. Standard analytical methods for these compounds are are complex, require specialized equipment, and typically target only a single analyte. Their detection limits are relatively high, making them unsuitable for trace level monitoring. As a result, a reliable reliable multi-component method for continuous air quality assessment are still lacking. Most of the existing techniques are also labor-intensive, and take time-consuming, often involving solvent extraction or derivatization, and they do not enable simultaneous determination of several compounds. Therefore, there is a need for sensitive, accurate analytical methods capable of quantifying multiple UDMH transformation products in air. UDMH transformation products in air. So, the main objective of the research was to develop analytical methods for quantification of UDMH transformation products in air that are cost-effective, simple, accurate, and capable of detecting multiple compounds simultaneously. The three specific tasks were addressed to develop method for quantification of UDMH transformation products in air using SPMA combined with gas chromatography and mass spectrometry. Second was to develop method for on-site analysis of UDMH transformation products in air using SPME combined with gas chromatography and nitrogen phosphorus detection. And the third one was to develop methods for quantification of UDMH transformation products in air using sorbent tubes and gas chromatography with high-resolution mass spectrometry detection. The main provisions to be defended was set as first one is optimal solid phase microextraction time for extraction of unsymmetrical dimethyl transformation products from air in 20 milliliter vials using SPME fiber, which provides best combination of detection limits and apparent recoveries when analyzed by GCMS is 5 minutes. Second provision is increasing air sample volume from 20 to 250 milliliters and SPME time from 5 to 15 minutes using PDMS SPME fiber reduces detection limits for UDMH transformation products from 4 to 10 to 0.3 to 2 micrograms per meter cubic when using portable GC and PD. And the third was to use the use of sorbent tubes packed with 10xTA at air sampling rate of 200 milliliters per minute provides highest recoveries and best detection limits for unsymmetrical dimethyl transformation products in air among all tested sorbent tubes when analyzed by GC HRMS. So, dissertation consists of three main studies corresponding to the three peer-reviewed publications. Together, these studies provide comprehensive framework for trace level air analysis. The first part of the study was focused on the developing a laboratory-based method on solid phase microextraction with gas chromatography and mass spectrometry. This method was aimed at establishing reliable solvent-free and solvent-free approach for simultaneous quantification of multiple UDMH transformation products in air under controlled laboratory conditions. The main sample preparation techniques was set as solid phase microextraction, which is solvent-free sampling and pre-concentration technique that based on the extraction of analytes to the adsorbed to thin polymer coated fiber and thermally desorbed into gas chromatograph inlet. Because analytes are completely transferred to the gas chromatograph, it minimizes the sample loss and improves sensitivity and can be a ideal approach for volatile organic compounds analysis. To use solid phase microextraction, first we should optimize desorption and extraction time, and due to strong affinity of analytes to fiber and slow mass transport inside the coating, increased desorption time resulted in high recoveries and high responses of analytes. And the best combination of responses of analytes and their RSDs was achieved at the desorption time of 3 minutes. The extraction time was optimized at 5 minutes. This provided the best compromise between analyte recovery and precision. Shorter extraction time due to led to incomplete absorption of equilibrium for several analytes, which while longer extraction time did not significantly increase peak areas. Therefore, 5-minute extraction time was selected as optimal. Next, the effect of vial type was studied and evaluated by comparing amber glass vials, clear glass vials, and foil-covered glass vials. Amber glass vials provided significantly higher responses for light-sensitive analytes, increasing their signals by 24 to 100%. Amber glass vials also reduced signal variability, and relative standard deviation of these signals were ranged from 2 to 6%. Therefore, amber glass vials were selected as optimal for SPME extraction to ensure analyte stability and reproducibility. The storage stability of air samples was evaluated at 3 concentration levels. At 10 micrograms per meter cubic concentration, concentrations, significant analyte loss occurred after 24 hours for most of analytes, and the signal decreased by 17.37%. At 50 micrograms per meter cubic, relative responses after 24 hours ranged from 82 to 104% for most of analytes, and at 500 micrograms per meter cubic, all analytes showed high stability with responses of 89 to 101% with of initial signal with RSDs lower than 4%. Therefore, accurate quantification is possible after up to 24 hours for storage for moderate and high concentrations, while low-level samples require on-site analysis or rapid transport to prevent losses. The method showed great, excellent linearity over both calibration ranges, with determination coefficients higher than 0.99, and detection limits were ranged from 0.12 to 0.5 micrograms per meter cubic, with apparent recoveries ranged from 88 to 130%. Together, these results confirm that the development method SPME GCMS method provides high sensitivity, linearity, and precision across wide dynamic range suitable for quantifying both low and elevated concentrations of UDMH transformation products in air. The developed method was successfully applied to analyze the headspace above soil contaminated with UDMH transformation products. In the way it was a method to prepare model samples, air samples. All 7 target analytes were detected at concentrations from 2 to 37 micrograms per meter cubic, with highest levels for MPA, NDMA, and DMAF. To further demonstrate the method applicability, soil-air partition coefficients were calculated. The second part of the study was focused on developing on-site analytical method based on the solid phase microextraction combined with portable gas chromatography with nitrogen phosphorus detection. This approach was designed for rapid field analysis of UDMH transformation products in air directly at rocket stage fall sites. To implement this method, air sampling was carried out using both 20 milliliter vials and 250 milliliter vials of gas sampling bulbs, and the extraction time for bulbs was optimized to achieve the best analytical performance. During optimization, extraction time from 1 minute to 60 minutes were tested, and modeling with COMSOL multiphysics showed that 95% of the equilibrium amount of analytes would be reached only after 33 to 51 minutes, depending on the compound volatility. However, experimentally extending extraction beyond 15 minutes led only to not substantial increases in peak areas, while significantly increasing analysis time. Thus, the 15-minute extraction ensured near equilibrium sorption of most of analytes, while remaining practical for the field use with portable GC and PD system. The 20 milliliter vials extraction, use of 20 milliliter vial extraction with SPMA, GC, and PD provided adequate sensitivity, but was less efficient than 250 milliliter configuration. The 20 milliliter vials showed from 5 to 13 times higher detection limits and correspondingly lower analyte uptake on fiber compared to optimized bulbs, where recovery ranges from 94 to 118%, and the LODs were ranged from 0.3 to 2 micrograms per meter cubic. Also, during this study, during field approbation on-site, SPMA, GC, and PD method was tested for long-term passive screening of UDMH transformation products in air. Modeling showed that 24-hour extraction from open air would allow absorption of 96% of the equilibrium amount of analytes, giving from 2 to 3.5 higher uptake than 15-minute extraction from 250 milliliter gas bulbs. However, during this study, no analytes were detected, likely due to long time elapsed since the spill and the low residual contamination levels. The third part was the third part of the study was focused on the developing a thermal desorption gas chromatography with high resolution mass spectrometry. This method was designed for ultra sensitive analysis of VOC in air, where concentration are often at trace or sub-trace levels. It combines sorbent tube sampling, thermal desorption, and high-resolution mass spectrometry to ensure precise identification and quantification of multiple compounds. To optimize this method, study systematically evaluated the 5 sorbent tube materials to identify the optimal option for sampling UDMH transformation products in air. The 10xTA and Carbograph 1TD showed the best overall performance, providing high recoveries ranging from 93 to 114% with low RSDs below 4%. And the Carbograph 1TD was retained as a cost-effective alternative with comparable analytical performance for most of analytes. After that, the effect of sampling flow rate was evaluated, and the sampling flow rate was investigated using 10xTA and Carbograph 1TD sorbent tubes to optimize analytical recovery and minimize breakthrough. For Carbograph 1TD, recoveries ranges from 56 to 133%, with highest values ranged from 106% to 126%, and achieved at 50 milliliters per minute sampling rate. However, at 500 milliliters per minute, recoveries for several analytes dropped sharply to from 56 to 88%, with increased RSDs up to 31%. For 10xTA, recoveries were more stable and ranged from 82 to 125%, and were optimal between 200 and 400 milliliters per minute, with minimal differences across most of analytes. Based on the combined recovery reproducibility, the optimal sampling rate was determined as 250 milliliters per minute, or 200 milliliters per minute, which ensured efficient analyte capture. As you can see, the method shows excellent linearity for most of analytes. The RSDs of the calibration slopes are mostly below 2%, were mostly below 2%, confirming high reproducibility. The method is extremely sensitive. The limit of detection ranged from 0.08 to 1.1 nanograms per meter cubic. And recoveries for all of analytes are within 76 to 112% across all the tests at spike levels. And the precision also was evaluated, and both intraday and interday, and the precision remained below 18% for most of analytes, and always was below 22% for tested spike levels. To simulate conditions at the rocket stage fall sites, contaminated sand treated with an oxidizing agent was used as a model system for UDMH decontamination. The sand sample was spiked with UDMH, hydrogen peroxide, and catalyst solution and thoroughly mixed. And after that, the air above the sand was sampled using sorbent tubes. Air above the soil sample, sand sample was sampled over 12 days to study how transformation products evaporate and degrade over the time. And all 7 transformation products were successfully detected and quantified with initial concentration of the air ranging from 3 to 287 micrograms per meter cubic. The highest initial concentration were found for dimethylamine acetonitrile and the nitrose dimethylamine, while tetramethyltetrazine and the methylformamide were the lowest concentration and ranged from 3 to 8 micrograms per meter cubic. This result shows that the method can effectively track temporal changes in the emission of the transformation products in air during decontamination and provide insight into their persistence and the volatilization behavior under near real conditions. The current method significantly improved sensitivity. The SPMA GCMS method detects 7 analytes with detection limits of 0.12 to 0.5 micrograms per meter cubic. The portable SPMA GC-NPD method can achieve LODs of 0.3 to 2 micrograms per meter cubic using a sampling volume of 250 milliliter gas sampling bulbs. And the TD thermal distortion thermal distortion gas chromatography with high resolution mass spectrometry method achieved ultra low limits of 0.2 to 3 nanograms per meter cubic, about 1,000 times lower than the previous method. Together, this method provides full coverage from rapid field screening to ultra trace laboratory analysis. And in conclusion, the three complementary methods were developed and optimized. The research established a comprehensive set of analytical methods for determining UDMH transformation products in air. First is laboratory-based automated SPMA GCMS method. Second is portable on-site SPMA GC-NPD method approach for field analysis, and highly sensitive TDGC HRMS method for trace level quantification. Developed methods significantly advances analytical capabilities of assessing air contamination related to the rocket activities in Kazakhstan, and they can provide a scientific basis for evaluating human exposure, improving the environmental safety near rocket fall sites, and guiding future regulatory and remediation strategies. As a result of the study, 3 articles in international peer-reviewed journals were published in first and second quarters, according to the Web of Science. In the end, I would like to express my sincere gratitude to my scientific advisor, Professor Bulat Knyazov and Dr. Dmitry Kosякov, for their guidance, support, and valuable advice throughout my research. I'm also grateful to my colleagues and friends, Associate Professor Nasiba Baimato, Dr. Olga Bergimu, and Dr. Anna Romaro. Thank you for your attention.
Thank you. The presentation is complete. Dear colleagues, do you have questions to the applicant, Bauyrzhan Bukenov? Please, you can ask. Изображением. Говорит. Да.
Dear colleagues, just briefly, I will explain the procedure. The procedure is now time for questions. Any questions for applicant? It's so you can ask any questions regarding his thesis, the papers, and so on. And after that, we will give the floor for supervisor, and after that, for reviewers. So now the time, if you have any questions, including reviewers, so Professor Woojin Lee, Professor, also the question can be from the hall here. So.
Well, all of these are already proven by the peer reviewers in the research journal. So I really don't have any specific, question, but I'm just quite kind of the environmental engineering remediation side, a couple of things. Actually, these, pure chemicals are quite persistent, right? So because of that, it is very difficult to, remediate from the contaminated soil and also contaminated groundwater. So because of that, mostly we are caring about the soil contamination and target contaminant and its transformation products from the soil and groundwater. And also its natural fate and transformation. Those are quite, important. But here, the candidate actually studied for the concentration of the target chemical and also transformation products in the air.
Just a moment. We will give a floor for you, but I mean, now the session is for question. The question. If you have question for candidate.
Yeah. So I have a question. So I'm just quite wondering. So is the all of those transformation products coming from atmospheric reduction with hydroxylradical or oxidation radicals, or are these actually simply coming from soil or groundwater contamination? So
Okay.
any idea on this one?
Yes, thank you for your question.
Mhm.
These compounds are produced by the unsymmetrical dimethylhydrazine itself, so
Yeah.
they're not coming from the ground or water. This compound is released into the environment and goes through the oxidation reactions or reacts with oxidating agents usually used to do the decontamination procedures, and they can be released. They can be temporarily released. Can be in air, and mostly they stays in the soil with continuous evaporation from the soil to the air.
Well, yeah, you're just talking, to me right now. So the fuel can stay on the earth, and then there are many oxidant and reductant, natural reductants and oxidant in soil and groundwater. For example, ferrous iron, and also any other different chemical species can be kind of the redox active material. So it could be from the soil and groundwater reactions. But in the air, we have quite a high concentration of hydroxyletical, peroxyletical, or nitrate, or something like that. So, well, actually, I know you are not actually focusing on that. You're just focusing on the measurement of these target compounds, right? So I'm just curious, uh, are those actually, you just have consider about the reactions actually? That's my question.
So these compounds are produced by the reaction of with mostly they produced by the reaction with the hydrogen peroxide, which is used during decontamination. So hydrogen peroxide is catalyzed catalyzed the degradation of hydrogen peroxide, and this hydrogen peroxide produces the oxygen, reactive oxygen that reacts with dimethylhydrazine residues in soil. So this reaction mainly produces these compounds, but also these compounds can be produced within the compounds or oxidized can be reacts with compounds which are in soil also.
So hydrogen peroxide, what is the source of the hydrogen peroxide?
Hydrogen peroxide is produced by from the compounds which spread on the contamination site. So it can be in pure form or formed from the
Engineering purposes, you are just spreading hydrogen peroxide for making oxidation for the soil remediation. Is that right?
Yes, so the hydrogen peroxide is made from the reaction. I forgot the name of the agent that used during the contamination, but it's formed from the organic compound which spread during the contamination.
Okay, maybe I will ask you specifically a little bit later. Okay, thank you.
Any more questions? If I have one, if I have question, if possible, yeah, dear colleagues. But please, Professor Pino, Professor Attilio, also, if you have questions, just. But now I have
Yeah.
questions. So
I have a general question, if you.
yeah, you can
if
ask.
I
You can
can.
ask.
Yeah. So you presented. Congratulations for your work, first off. You presented several methods, different methods. Some of these methods use active sampling, other passive sampling. But which one would you suggest for routine analysis? If you have to use these methods for routine analysis, so considering all the potential aspect, also the greenness, the throughput, which one would you suggest?
Okay, thank you for your questions. So comparing all three methods, they have all some disadvantages and some advantages over each other. And if I would choose the one for routine analysis, it will be SPME GCMS method. So even if it has a lower, not so low LODs, but it achieves the regulatory amounts, regulatory concentrations can be detected by this method. And the main advantages for routine analysis, it will be the possibility of optimization. So it can be air can be sampled into 20 milliliter vials and analyzed using autosampler and with gas chromatography mass spectrometry.
Okay. And for the active sampling methods, the ones with the cartridges, 10x cartridges, have you tested the storage time of the cartridges? The cartridges needs to be analyzed in few hours, few days, or can be delivered, because this can be another solution, sampling on site and then deliver the cartridges to specific laboratories, for instance.
Thank you. The stability or storage time of the samples collected into the sorbent tubes were not evaluated. However, we refer to the compendium method for the analysis of using sorbent tubes, and it was recommended that it was specified that this tube can be analyzed within 3 to 5 days of the after this sampling, and while being stored at near 0 degrees of Celsius. Why we did not study this stability or stability of the samples? It was done because we had we analyzed all the collected samples during sampling from model samples from model air. We analyzed them immediately, so we did not have any need for this. But we can also refer to this compendium method that specifies this storage of the sorbent tubes.
Okay, thank you.
Hi, I would like to ask few questions. The first one will be in your last article, the one you combine GC with high resolution mass spectrometry with an orbit trap, and you're using in this case a sorbent tube for the method of extraction. But in your first article, you were using SPIMI fibers, right? So I was wondering why, if you have already all the optimization of validation of the method using SPIMI fibers, why now that you have the opportunity to use high resolution mass spectrometry, why you didn't compare the performance of both microextraction methods, the one using headspace, solid phase microextraction, with this new approach using the different sorbents? Because right now you don't have the same sample compared with the two different procedures, but the same separation and detection system. That could be interesting to, I don't know, give even more value for your last study, right?
Thank you for your question. Yeah, you're absolutely right. The comparison of the development method using sorbent tubes with SPME fiber method would be very helpful to have stronger results. However, this method was optimized. When this method was optimized, we thought that simple comparison of the development developed method with results obtained during previous studies would be enough. This is why.
Yeah. Because I was wondering a similar thing between your first and second article, right? Because it's true that in the first one, you were just focusing on 20 milliliter vials, and then you get these bulbs to kind of mimic a higher gas volume and everything. But I was wondering if, in that case, if you compare how is the performance of using directly on site the portable GC-MPD detector with the once you get your sample trapped by the SPME fibers and then you go to the lab, then you have the perfect evaluation of both approaches, on site or sampling and then further analysis, right?
Yes, right. The comparison of the on-site method also was not done due to the different times of this method was developed in different times. So the high resolution method was developed before the on-site method actually, and the on-site equipment which we used to develop on-site method was not available at the moment when we developed the high resolution method. This is why they not compared to each other like at the same sample also.
Yeah, it is. And well, and one last question, because in the first study, like you were like using amber glass vials because the hypothesis is like you were maybe experienced some kind of photo degradation of your compounds, right? Maybe that was the reason behind the proper choosing of this type of recipients for sampling. And you also observe, for example, that if there's a low content of your compounds, then it's better to do not wait more than 24 hours between the sampling and the analysis, right? But then in the second article, I swear that the solid phase extraction time was like 24 hours. So I was wondering, because in that case you have the fiber directly, exposed to the air environment. So I was wondering if you can maybe are getting those issues also for low content compounds, right?
Thank you for your question. So the purpose of this of the use of amber vials was to reduce the analyte losses so during the storage also, and when we were doing the 24-hour extraction, it was not done in vials. It was done like directly to the fiber. So if you're asking if we had why we used this method, because the losses can be significant too in during this sampling. During the storage during the storage time evaluation, at this case, I think at lower concentrations, the decrease of concentration, the decrease of decrease of signals of analytes were due to mostly due to the absorption of analytes into the glass surface of the vials, not due to the losses during the extraction or due to the losses of due to degradation of the compounds itself.
Yeah, that makes more sense. Okay, thank you.
I have some questions basically related with the sampling and some curiosities. I find it very interesting that you have selected this sampling zone as a result of the rocket launching, but do you have information about the levels of pollution in this region? I mean, concentrations of these compounds in soils, water, or possible effects in population. Do you have any background information about that? I mean, I know that the group has studied this place quite often and these problems quite often. So I was wondering if this is really causing a problem in the region, and if you have more information about it?
Okay, thank you very much for your question. So we do have some data on the concentration of these compounds in soil, reported a number of times in different articles. However, the monitoring of these places are done regularly each year by the specialized agency. Also, we have some data from the 2000 year. So there was some reports on the concentration of these compounds, which were affecting the animal and human health. But there was only suggesting that these compounds can that these compounds were in the soil, not in the air. And also there is some studies recently were published studies that reported that these compounds can be persistent and retain in the soil after the years after the launch of the vehicles.
Okay, thank you. It's good to know. Good to know that these monitoring programs are being developed on a regular basis. Regarding your first paper, I was wondering. I have some curiosities, basically related to how you did some things. How was the soil sampling procedure developed? I mean, how did you the soil in the first work? Basically, how did you collect the soil and take it to the laboratory? I mean, sampling on-site sampling. I mean, on-site sampling.
Thank you very much for your question. So the soil collected used for the application here was collected a long time ago. It was the soil collected during the crash or accident of the Proton M launch, where 600 tons of the fuel were released into the environment, and this soil was highly contaminated and used in the and were stored in the lab for for almost 8 years. And this soil was collected by the special agency, with which we are collaborating, and they provided these soil samples to us.
Okay, thank you. And in that first work, regarding the incubation, you have it there on the slide, the incubation for 24 hours at 40 degrees Celsius. How did you selected these conditions, or do you think that this incubation time is more than enough to fully volatilize the compounds?
Mm.
Were these previous conditions, or I mean?
Thank you for your question. So these conditions were selected just to give time to release these compounds from soil to the air. There was no purpose of the complete extraction, not complete equilibrium between to achieve the complete equilibrium between the soil and the air. And we did this experiment to actually to sample the contaminated air to get to, because we don't have regular access to the places where we can analyze or sample air contaminated with these compounds, because these places, sampling sites are very far away with no conditions to travel them to these places very easily.
And thank you. And do you need special permissions for to reach the zone and to sample, or you just can freely go there?
No, we cannot get we don't have access to these places. So the access to these places can be achieved by through if you have a special request, and we have to get the special vehicles to get there because there is no any roads, and it was just a step with no any like civilizations.
No, good to know that and also to put on the table that this type of difficulties. And one last question, just a curiosity: how portable is the GC NPD NPD chromatograph? I mean, because when I have been reading the article, it seems that it's I mean, you have to take it with a big car and lots of things. Is it really portable? Do you think it's really useful in this sense, or it's much better to keep it on? I mean, this device that you have, or is it better to, despite the long distance of the place, is it better to keep it in the laboratory? Do you think it's worthy with this equipment that you have going there with all these portable devices? How portable it is?
Thank you for your question. So this device which we used is portable, but it can be there are models that can be used easier in the field sampling or in field analysis. But this one particularly, this installation was not very hard, but not very easy. So we had to have a car with the equipment, all the equipment loaded to this car, and also we needed to have a constant source of the electricity. So we had to use gasoline to generate electricity to run this analysis.
Okay, thank you very much.
Yeah, thank you. So I also have a few questions, actually, if possible, regarding abstract. And I read this abstract. I tried at least carefully. And the questions, of course, for provisions. So here, the first provision, you said that the optimal time is 5 minutes. The one of my remarks is that provisions here in abstract is different than provisions you hear. At least SPMA you write, but here you write solid phase macro extraction. But
I just abbreviated them to.
yeah, you don't. Yeah, it's you can't abbreviate them. You need to no, because it's but the question is 5 minutes. You said, yeah, the optimal time. The main questions is how you proved that the 5 minutes is optimal. I mean, you prove it's somehow statistically. It should be different type of extraction, yeah. But you said that here that optimal is 5 minutes. The question is how you proved that optimal time is 5 minutes. Okay. The answer. The question is clear. Okay.
So we did the optimization of the extraction times, and we concluded that the 5 minute extraction time is optimal due to a number of reasons. So the lesser time was not enough to extract most of analytes, but the more time of the extraction led to the some deviations, and also the mass or amount of analyte extracted to this fiber was not substantially increasing. Thus, we concluded that 5 minute extraction is optimal. And after that, we used this time to evaluate the recoveries and to plot calibration curves, and to obtain the LODs, calculate the LODs and the LOQs.
Actually, you know, it's you 5 times, and here probably less than 5 times. It can be 4 minutes. or can be 7.5 minutes. And of course, do you think that we need to apply the statistical approach to prove it or not?
Well, these measurements were done in the triplicates, so there is some statistical approach.
I mean, my question is probably 5 minutes or 10 minutes or 2 minutes can be not different significantly. I mean, from the statistical point of view. Okay, this is just the second. Regarding second provision, you said that increasing time from 5 to 15 minutes, you improved a detection limit. My questions regarding this provision, can we predict it? I mean, can we predict it before doing experiments that detection limits can improve by increasing time or not?
We can do that with computational methods somehow, but here we did it experimentally and using the gas chromatograph with nitrogen phosphorus detection.
So the question is why you think this provision is important if we can predict it, that detection limit can be increased. I mean, if you will take 20 or 40 or half an hour or an hour, probably we will get better detection limit. One of the criteria for provision is that it shouldn't be, how to say, I don't remember, it's a Russian, it shouldn't be trivial, yeah? It shouldn't be trivial. I mean, why do you think that your provision, the second provision, is trivial or not trivial? It's just a question. Just try to answer, okay?
So I think it's not obviously trivial.
Yeah.
But because there was optimization of the extraction time and optimization of extraction time for the 20 milliliter vials in previous studies, in previous paper, and in this case, the 15 minute extraction time was also optimized for the 150 milliliter bulb gas sampling bulbs. So I think it's not very trivial, but it can be looked like trivial.
Yeah, okay, but anyhow, I think still think because yeah, I think probably something is missing. But another question regarding this second provision is, do you think if we can change some parameters of chromatographs, like voltage of something or flow of gas and so on, and using this changing of these parameters will affect the detection limit or not?
If we're talking about the change of the voltage, it can be, but it should be proved experimentally, because the voltage on the detector can be different at the different times. It depends on the how much we use this detector, so it can be.
Okay, the flow rate of the gas will affect the detection limit or not? Here.
It will affect the shape of the peaks on chromatogram. Then if there are no any other like noise peaks, it can improve or decrease the detection limit.
Yeah, that's why I am asking, because you using portable GC and PD, you need to specify which conditions. It's once again, I'm not expert. I'm just trying to and the final third provisions. You said that you tested many sorbents, but I didn't notice from your presentations this. You said that you tested sorbent use among all tested sorbent tubes. but I didn't notice, probably I missed it something somehow, or which sorbent tubes you studied.
So there was 5 types of the sorbent tubes. 2 of them were manually packed, and 3 of them was commercially available, already commercially available. And there was 2 carbographs, carbon-based tubes, or 10XT and universal tube, and semi-volatile organic compound tube for the for analysis of semi-volatile organic compounds provided by the producer of this tube.
And somehow you choose the 10x TA as a best. You write here that it's almost the best tubes among the studied. But again, how you choose these 10x TA among the best? This is the first question. And the second question: do you think that this third provision have quite practical significance? I mean, probably. What kind do you think that this third, how we can use this third provision in practice? So this is the question. Yeah. Okay.
Okay, thank you. So the 10XT was chosen as it showed best overall performance, providing high recoveries and lower RSDs. So recoveries were between 93 to 114%, and RSDs were below 4%. And as for the provisions, it has practical application. So it states how these compounds how these compounds can be analyzed by the 10XTA sorbent tubes with combination of gas chromatography and mass spectrometry.
Yeah, the problem is for practical because using the third provision, all will now use this 10x for this determination of these compounds, but probably the price is also important. And do you compare them with the same conditions? I mean, the same mass of sorbents. The conditions was the same, yeah. So then you get. I mean, the another questions here arise that why 10x TAs show these good parameters. I mean, it's compositions of 10x or something like this.
Okay, so the tubes were packed that were packed by the commercially available tubes. They were packed at the producer side. So they have established the composition, and the mass of the sorbents are uniform from one tube to another tube. But if it's labeled 10XT, it should be similar to each other. If we talking about comparing the 10XT, for example, with the universal tube, they have different content. Universal tube has more different sorbents, which designed to trap, for example, water, or to design to not form artifact with a specific group of compounds. With 10XT, it's more or less universal because it's hydrophobic material. It can retain the mid-polar compounds, but will not extract in great great amount of the other compounds that can be present in the air.
Thank you, Bauyrzhan. And my last, almost last, it's just because I probably you have answer for these questions, and slide number 18. Slide number 18. And I noticed that you showed the here. For instance, you showed the slope for 1 MPa. The uncertainty is why you didn't. You see that the second and third, the first and second, after 1 and 2 should be 1 digit, something like this. But you You didn't show it. Why? From in the first, from the after two should be some. Otherwise, we don't know. It should be from two. We need to see something like 5 or 3 or 9, and from after one we also need to see some. Okay,
Yeah.
why you missed here?
So this is probably the typo, but it was less than 0.01. So we had to like I wanted to place to show this these values as uniform. So this is why I did the 0.00.
Because from all other places it was okay, but here
Yeah.
you finally did it. I don't know why. Probably some reason behind. Okay, thank
Yeah.
you. Yeah.
Okay, I have one question to Bauyrzhan. Bauyrzhan, please. The aim of the dissertation and one of the second of the main results, you indicate about cost developed methods, namely, the method developed methods is a low cost. Okay, and could you explain how you estimate the low cost of the developed methods and where exactly this is reflected in the article as the evidence?
So the cost of the method or the estimation of the cost of the method mainly depends on the equipment that we use during the analysis. So if we act to evaluate these methods by cost, so the lowest cost method will be on-site and on-site. The method based on the portable gas chromatograph with mass spectrometer, with nitrogen phosphorus detections, and the second will be the mid cost, I would say, but it's still considered can be considered also lower cost than other method as GC MS method with SPME method with SPME extraction, and the highest cost would be the method based on the sorbent tube extraction with high resolution mass spectrometry. It will be most expensive.
Did you some calculation?
No,
Which was a
well the there is no calculations on the calculations on the cost of the methods, but it can be stated from the like I said, the cost of the equipment that if we have like portable nitrogen phosphorus detection gas chromatograph with nitrogen phosphorus detector, it will be lowest. It will have the lowest cost, and the highest cost will be the high resolution mass spectrometers.
Okay, thank you.
Да, тоже такой вопрос. Вот смотрите, вы говорите о объеме виалы от 20 до 250 миллилитров, да? И даже толщину указываете 85 микрометров. То есть это решающее какое-то значение же имеет, да, для виалы? Вот толщина и объем от 20 до 250.
Нет, здесь 85 микрометров, это имеется в виду это покрытие, то есть толщина покрытия волокна.
Толщина
20,
покрытия.
20
То есть вот эти характеристики имеют значение, да?
Да, они влияют
То есть они влияют на степень определения и прочее.
Да.
Вот скажите тогда, пожалуйста, вот 20 и 250, все-таки для аналитической практики это очень большой разбег. Я бы понял там 20 и 35, ну 20 и 28, да? 15 и 20, но 20 и 250. Насколько это корректно, такой вот резкий скачок, и насколько оно влияет на степень определения? Потому что 20 и 250 – это прям вот как Как километр. Ага,
Так,
пожалуйста.
Спасибо за вопрос.
И еще потом, ну, потом.
Спасибо за вопрос. В целом 20 и 250 это относится к объему пробы, то есть 20-миллилитровый почему было выбрано? Потому что это стандартный объем виалы, который используется для анализа в газовой хроматографии у нас.
Мгм.
250 почему? Это минимальный объем колбы, стандартной колбы, которая используется для отбора воздуха. То есть там есть, конечно, колбы, которые используются на 125 миллилитров, но меньше не бывает. То есть вот этот 50 миллилитров, если есть виалы, но они не используются для газовой хроматографии, то есть они используются для других целей, таких как там жидкостная экстракция или что-то подобное.
То есть на степень определения, да, или на, как сказать, на концентрации это не повлияло, да? То есть разницы нет. Вот у вас стандартные 20 и 250, да? То есть
Нет,
150, там, 170, там, 100, то есть разницы нет, смысла нет.
нет, разница есть.
Или
то
под
есть,
рукой не было.
здесь просто имеется в виду то, что есть доступное, то есть 20 миллилитровых,
Ну, это
20
корректно.
миллилитровых виалы, и это нормальный, нормальный стандартный объем виал. Есть 250 миллилитровые колбы, которые тоже используются для отбора воздуха. Они есть, естественно, влияние на пределы обнаружения от изменения объема воздуха и от изменения времени экстракции. Оно будет влиять.
На вашей методике это не повлияло.
Нет, оно влияет. Почему? При 250-миллилитровых колбах предел
А ваша
обнаружения
методика
уменьшен.
для какой объема?
Первый метод, описан в первой статье, он для, для виал с 20-миллилитровым объемом. Второй метод для виал 20-миллилитровым объемом и 250-миллилитровым объемом. Третий не использует виалы, это для того, чтобы использовать с сорбционными трубками.
Ну, хорошо. 22 слайд можно? Я так понимаю, это коммерческие сорбенты, да? Которые очень хорошо. Вот смотрите, когда мы говорим, да, это же производные несимметричного диметилгидрозина, да, все вот эти компоненты. То есть так или иначе они вот как бы произошли от одного какого-то материнского химического соединения, да? Соответственно, они где-то между собой, ну, понятно, там функциональные группы разные, но где-то они приблизительно рядышком, да, по размеру молекулы, там, прочее, по своим характеристикам физико-химическим. Здесь вот я вижу, да, вот смотрите, у вас начиная от ДМАН, да, и дальше. Ну, вроде бы где-то как-то в пределах погрешности хорошо идет. А почему ТМТ вот так вот сильно выпадает, вот, допустим, для любого вот сорбента, кроме вот серого и желтого? Они как-то вот в той же погрешности держатся. А вот эти два сорбента, они вот резко, вот прям вот небо и земля отличается. За счет чего это так вот, такой вот, ну, картина вот такая вот некрасивая складывается? Объясните, пожалуйста.
Данное явление может быть, можно попробовать объяснить тем, что сродство вот этих материалов, из которых сделаны вот сорбенто-сорбционные трубки, оно просто не похоже со структурой тетраметилтетрозена, который был использован здесь. Здесь, ну, то есть сродство аналита с сорбционной поверхностью, с ассоциированным материалом меньше, чем с другими просто. Все. А как раз здесь TNXTA, он подходящий для этого вещества, ну, сорбент.
Ну, хорошо, ладно. Спасибо. Будем считать, убедили.
Do you have any questions, dear colleagues? Okay, are there no more questions? Yeah? The floor is given to the next scientific supervisor, Bulat Kinesov, PhD, professor of the Department of Analytical Colloid Chemistry and Technology of Rare Elements, Al-Farabi, Kazakh National University. Please.
Hello, dear colleagues. First of all, I want to thank for very interesting discussion, very interesting questions. So this topic, the topic for this dissertation arises from the problem which we had. So we previously focused mainly on soil pollution and water. So the methods, the good methods for air samples were not available. Yeah, and we struggled for like many years, so we couldn't measure. Okay, so the goal of Bauyrzhan was develop a set of methods. Yeah, so that will be suitable for different cases. Yeah, so actually he developed 3 different methods which are useful for different scenarios. First, for example, the first method with 20 milliliter vials is mostly for the low cost analysis of many samples collected in the field. Yeah, second is on-site method, which you can take the instrument to the field and quickly analyze after, for example, some emergency case. Yeah, so if the rocket crashed, so you can take the instrument, go to the field and collect the data immediately about the pollution level. And because of all these transformation products are volatile, yeah, so we need to do air analysis. Yeah, so with soils, it's quite safe. Soil is there, and but the air is moving to the populated areas. So some people can be affected, yeah, and poisoned. So that's why it's really necessary. Yeah, and the third approach is the method based on the high resolution instrument with sorbent tubes, very sensitive. It's for like analysis of air samples from, for example, old places of fuel spill, like which were like maybe 10 or 20 years ago. Yeah, so we can go to the field and check. Unfortunately, we couldn't try that because we don't have such an instrument in our laboratory. So Bauyrzhan was happy to do this research in Arkhangelsk, where this method was available. Unfortunately, the time was not enough to develop the method based on solid phase microextraction. Yeah, but probably in the future we will have some study. Of course, if Dr. Kosyakov is interested. Yeah, and generally we have like very good results. Of course, there are some limitations of the methods, but they were clearly shown during the defense. Yeah, so Bauyrzhan studied everything quite well. Yeah, and he published 3 articles in strong journals as the first author. Yeah, so he is really like expert in this topic. Actually, the only expert in the analysis of air sample for transformation products of UDMH. Yeah, and because actually we were the first who started working with air. It was very difficult, and a lot of researchers like just declined this type of research. Yeah, and in my opinion, the results are good, and as I saw from the questions, yeah, so there are some drawbacks, yeah, which we probably work in the future on. Yeah, but still this dissertation is quite good, and Bauyrzhan is qualified, and in my opinion, he can be recommended for the PhD degree on the specialty chemistry. Yeah, so if you have any questions, I will be happy to answer them. Thank you.
Okay, thank you. Next. Do you have questions to Supervisor Bulat Kinesov?
I have questions regarding papers because candidate is defending of series articles, and of course, if you will give information about his contribution to papers, some brief information, yeah.
Okay, so I mentioned briefly mentioned that he is the first author of the paper, so he was writing the first draft of this all these manuscripts. Yeah, and then he actually participated in the revising of the article, responding to the comments. So everything, he was involved a lot. Yeah, so that's why he's like his input is very large into these articles. Thank you.
Thank you. The next floor, foreign supervisor, Dmitry Kosikov, PhD, docent, director of the Core Facilities Antarctica of the NASA Arctic Federal University, named after Lomonosov, member of the Scientific Council on Analytical Chemistry of the Russia. Please, Dmitry.
Dear colleagues, I would like to say a few words about the candidate for the PhD degree. I have been working with Bauyrzhan for a long time and know him as a highly qualified and responsible researcher, capable of tackling the most complex analytical problems. During two long-term internships in our laboratory at Northern Arctic Federal University, Bauyrzhan demonstrated excellent experimental skills and a thorough understanding of the theoretical aspects of the conducted research. The topic of Bauyrzhan's dissertation study builds on many years of research conducted by Professor Kenisov's team in the field of analytical monitoring of space rocket activities at the Baikonur Cosmodrome. However, despite the initial groundwork, the task assigned to the PhD student was really challenging due to the many specific issues inherent in air analysis and the need for dealing with a variety of unsymmetrical dimethyl hydrazine transformation products at extremely low concentration levels. And I believe he has accomplished this perfectly. This is confirmed among other things by high quality of Bauyrzhan's publications in top-ranked international journal. And as Professor Kenisov already said here, the contribution of Bauyrzhan to these publications was very high. And so I believe Bauyrzhan undoubtedly deserves to be awarded a PhD in chemistry degree. And I urge the members of the Dissertation Council to vote in favor. Thank you.
Thank you, Dmitry. Dear colleagues, do you have questions to Dmitry Kosikov? No, yeah? Okay. Thank you, Dmitry. Next, the floor is given to the first reviewer, Wujin Lee. PhD, professor at Nazarbayev University. Wujin Lee, please.
Oh, yes. I think those two advisors already talk about what Bauyrzhan actually did. I really don't have any, objections or anything. So as I already talked, mostly he did, very wonderful thing. As an environmental engineer who are majoring in who are working on the soil and groundwater remediation, we are actually seeing all of this contamination in soil and groundwater. And also the weather meteorology actually influenced a lot. So we even didn't, think about the evaporation or such kind of partitioning to contaminants to the air. So something like most of the EPA and ISO, methodology developed in United States and also European Union, they are mostly focusing on the water and also soil. I cannot say, atmospheric contaminant measurement usually easy, but anyhow, in that respect, I believe this research has kind of the novelty. Couple of recommendations actually. So this is kind of a little bit different type formats of dissertation defense. Mostly, researchers actually make a book called dissertation, but mostly here the candidate just show published paper, and then based on that, evaluators actually doing their evaluation. Because of that, one thing we can miss is how these papers actually correlated to satisfy the overall purposes and goals of the title of the dissertation, actually. Although the abstract actually briefly talk about it, I really want some of the abstraction portion could be revised to describe the each relation of the research papers, so that how those can be indicate and imply, for the application, and so that they can actually give some kind of the overall general idea for this, dissertation. And one more thing I'd like to talk about is actually US EPA developed some of the methodology. For example, US EPA 521 and US EPA 5270, and also European Union ISO 20596 2018. And all of those are actually very well developed methodology. Well, actually, those are echo sample and source sample. So based on that, if it is okay, Bauyrzhan need to compare all of those, not just simply, this is air sample, but overall, using, mass spectrometry and also sampling micro MS, some sampling gears, using all of those, if he can compare all of those so that he can provide some novel points from his, studied methodology. Yeah, I believe those two can enhance the quality of the dissertation, I believe. I really don't know if the Al-Farabi University doesn't need such kind of, permits. Well, my suggestion, recommendation wouldn't be useful. But anyway, but if it is, those two could be well described. Based on this, I think Bauyrzhan can, Bauyrzhan is eligible for receiving a PhD degree. Yeah, thank you.
Thank you. Doctor, the floor is given to the applicant, Bauyrzhan, to respond to the comments.
Okay, since there was no any notes on the thesis, I would like to thank reviewer Professor Bukenov Lee for the recommendations and for the recommendations and for the review of the thesis work. Thank you very much. Sorry. So, according to your comments about the methods, it can be the comparison of this comparison of developed methods with previously reported methodologies can be done. It was done in the papers and in the thesis also, and during the presentation too. And this issue with the comparison with specified methods by you can be resolved with future studies, and can be the future the development method or can be applied for the analysis of real samples maybe, and then we can, for example, compare it with the methods, develop methods with the methods specified by reviewer. Thank you very much.
So, Professor Woojin Lee, I also want to note that please be until end, because all reviewers and temporary members need to vote. So please do not. And regarding your mention that abstract is not a clear indicate the. We agree, and now we were thinking about how to extend abstract. Because now I also read the abstract and because we have here the space limit for abstracts, 5 pages, that that candidate can't describe all the moments. But I agree with you, and we discussed about that in case of series of articles, probably we need to give more spaces in abstract so the candidate can describe in detail. This is also as Professor Kinisov said, that we have some kind of shortcomings and also some things for developing in the future. Yeah.
Okay.
Okay. The floor is given to the second reviewer, official reviewer, Шолохова. Так, Анастасия Юрьевна, candidate of chemical sciences, leading researcher, head of the laboratory of smart methods of chemical analysis, Brunkin Institute of Physical Chemistry and Electrochemistry, Russian Academy of Sciences. Anastasia Yurievna, please.
Thank you for the opportunity to be a reviewer, developing sensitive and reliable methods for the simultaneous determination of multiple transformation products of unsymmetrical dimethylhydrazine in air is an important task in environmental analytical chemistry. The study combines effective analytical approaches, including high-resolution mass spectrometry to achieve low detection levels. The results of the study strengthen the scientific basis for air pollution monitoring in regions affected by missile activity and have both theoretical and practical implications for environmental safety and risk assessment. The dissertation is presented as a series of peer-reviewed publications in which the candidate is the first author of 3 and the corresponding author of 1, clearly reflecting his leading role and significant personal contribution to the conceptualization, experimentation, and interpretation of the results. The publication forming the dissertation are logically interconnected and collectively contribute to achieving the main research objectives, clearly demonstrating that the content accurately reflects the scope and purpose of the dissertation. The relevance of this dissertation is well-founded. The purpose and objectives of the dissertation are fully consistent with its topic. The new analytical solutions and methodological approaches proposed in this dissertation are substantiated and compared with existing methods. Dissertation clearly demonstrates the advantages of the developed methods, our previously known approach. There are some comments on this work. One comment: the study remains unclear as to why these 7 molecules were specifically quantified, as well as why the list of identified molecules differs across publication. Some components, such as NDMA, may be present in the atmosphere for reasons unrelated to unsymmetrical dimethylhydrazine. 2 comments. The study targets a defined set of 7 major transformation products, whereas recent high-resolution mass spectrometry screening studies indicate the existence of hundreds of possible intermediates and minor byproducts not covered here. 3 comments. The study lacks any further demonstration that the method is actually capable of detecting volatile unsymmetrical dimethylhydrazine transformation products at the concentrations they are present in the atmosphere significantly after rocket launch or crash. A single experiment at the Proton rocket used stage crash site showed that none of the onolith were detected. An experiment with soil samples from the launch site collected soon after the launch showed high concentration immediately near the launch site, which is less relevant from an ecotoxicology perspective. Then comments, the study's rationale appears somewhat outdated. Currently, virtually all rockets using unsymmetrical dimethylgenrazine in their lower stages are pushed out. There haven't been no proton rocket launches since 2023, and there likely won't be any in the future. Currently, persistent transformation products with higher molecular weights, which can persist in soil for decades, are of great importance. Then comments. It's unclear why one-site analysis using NPD is used instead of delivering samples to the laboratory and using GC high-resolution mass spectrometry, especially considering that transformation products weren't detected using NPD. Then comments. The dissertation also frequently mentions recovery rates statistically significantly greater than 100%. This phenomenon may indicate an unreliable estimate of the recovery rates and their uncertainties. Then comments. In figure 4, the concentration of subcomponents drops rapidly after the start of decontamination and then remains virtually constant for a long time. It remains unclear what causes the step of dependence and why the decomposition of the substance ceases. This may indicate a false positive detection. Then comments. The author connects the points of the curves using smooth curves splines, which is undesirable. Also, it doesn't affect the conclusions reached in the work. Stability of target analytes during storage of sorbent tubes or wells over extended periods, weeks to months, wasn't systematically evaluated, which could affect real-world sampling logistics. The comments made advisory in nature and don't affect the decision. They both demonstrate the scientific significance of the work and the author's suitability for the PhD in the educational program chemistry. Thank you.
Thank you. The floor is given to the applicant to respond to the review's comment.
Thank you for your review. According to your provided comments, the selection of seven transformation products were based on the established and predicted formation of pathways from the UDMH degradation, their volatility, and their toxicological relevance. And NDMA, MTA, and DMF were retained as main representative products. And the variation of the list of the analytes across the publication reflects the stepwise methodological development and optimization carried out during the project, during the study. The second comment is about the limited number of analytes versus high-resolution mass spectrometry screening. So the limitation is very unknowledgeable, and the aim of the study was not comprehensive identification, but rather the development of the robust and quantitative methods for the most relevant and frequently reported UDMH transformation products. According for the third comment is field detection of the volatile UDMH transformation products is inherently challenging, and due to the restricted access to the crash sites and the typically low concentration present in long after the contamination events, the absence of the detectable analytes in the field does not indicate the methodological drawback or failure, but reflects the realistic environmental concentrations below detection limits. And the method was successfully demonstrated using controlled experiments with contaminated soil and model samples. For the fourth comment, although UDMH use has declined globally, the legacy of contamination from the decades of use of Proton M launches remains an environmental concern in the Central Asia, in the countries where the UDMH is applied. The developed methods are directly applicable to the assessing of residual contamination and the studies to the studies at the fuel storage or maintenance facilities. Additionally, UDMH continues to be used as a upper stages and boosters for the rocket launches for several Indian and Chinese rockets that can be used also. This indicates that the method can be used in the studies involving this of storage of this fuel used in these rocket carriers also. For the fifth comment is the portable GC&PD method was introduced to test the feasibility of the rapid on-site screening immediately after contamination and when sample degradation or logistical delays could affect the results. While less sensitive than HRMS method, the NPD allows immediate quantitation and assessment without laboratory infrastructure. And this dissertation emphasizes that the field methods complement rather than replace the high-resolution methods. And the high-resolution method was not available during the initial field sampling, field analysis. To the comment referring the recoveries exceeding 100% is recoveries slightly or above the 100% are not uncommon in trace level quantification. Usually arise from the calibration slope variations, matrix effect, and small statistical deviation at low or trace level concentrations. And all recoveries were determined this study determined with replicate measurements with relative standard deviations within acceptable analytical limits, ensuring data reliability. And to the comment of concentration plateau in the decontamination experiment is the initial rapid decrease of concentration reflects on volatilization and removal of surface accessible compounds during the oxidation and followed by stabilization once only strongly adsorbed or less volatile residues remain. This behavior is consistent with diffusion limited mass transfer rather than the false positive detection. For the spline comment, the graph spline interpolation was used to purely visual clarity, and this was the actual statements and conclusion was made according to the obtained results based on the numbers that was obtained during the study. And according to the comments of long-term storage and stability of samples, as I was saying earlier, the study focused on the short-term storage stability of vial samples, but long-term stability of analytes and sorbent tubes under varying temperature and humidity conditions remains unstudied, and it can be studied in the future works. Thank you.
Thank you, Bauyrzhan. Anastasia Yurievna, are you satisfied with the answer?
I agree with the answer. Thank you.
Do you have any questions to Bauyrzhan?
У меня есть к рецензенту вопросы. Можно, да?
Да.
И вот вы написали в своем комментарии, что только одно исследование сделано field experiments, да?
Мгм.
И там мы написали, что большинство или практически все none of analytes were detected.
Да.
Что-то не могу найти я другую статью смотрю.
Мне кажется, это Separation Science, которая вторая, по-моему, это в 23-м году, если я не путаю, что там как раз было, что один эксперимент, ну, то есть реальный, и не обнаружено. Если...
Потому что
Да.
я читаю в
это-
23-м году, вроде
Ой,
что-то...
сингл эксперимент это Separation Science 25-го года, вторая, которая, да, правильно, 25-го. Ну, может, я не так поняла, не знаю статью.
Хорошо, я просто к чему-то говорю, что в этой статье я смотрел в другой, там они, наверное, что-то определили на реальных образцах. Тогда второй вопрос у меня возник, который... Спасибо, во-первых, что вы так очень внимательно все посмотрели. Вот второй вопрос. Вы оценили эти положения как среднего, среднего уровня, да, medium там написано.
Да.
Это из-за того, что из-за вот этого комментария, да, скорее всего, четвертого, в котором вы сказали, что currently, то есть сейчас не используется несимметричный. Или почему оценено как среднее, можно узнать?
Мне кажется, что для положений есть некоторая тривиальность. То есть нет каких-то выводов, а как вот результаты, которые получены. Там столько, вот вы тоже про положение спрашивали, что там такое-то время, такое-то там концентрация, еще что-то. То есть они как-то, мне показалось, что больше как выводы, а не как положение, поэтому я оценила как среднее.
Спасибо. Потому что я почему спрашиваю, первый рецензент тоже указал как средний, поэтому мне заинтересовал. И вот на вопрос 8 я сейчас прослушал, потом смотрел это. Здесь, я так понимаю, 8 комментарий, вы говорите о том, что он точки соединил, да, или я неправильно понял?
Да, он там точки соединил с сплайнами, а там, если посмотреть на рисунки в статьях, то там они есть минимум в одной точке, там 5 минут или сколько-то. Но как-то, мне кажется, не очень корректно объединять сплайном. Я понимаю, что это автоматически, но как не очень хорошо выглядит.
Да, я, кстати, с этим комментарием согласен. И как ты ответил? Как вы ответили?
Ну, то, что это для того, чтобы визуально просто видеть, как меняется концентрация, на самом деле, естественно, все выводы и расчеты были сделаны, ну, которые есть в статье, они основаны не на вот самом вот этом сплайне, а на тех данных, которые были получены реально. То есть цифры
Спасибо
были
большое,
реальные.
доктор Шолохова. Спасибо огромное.
Спасибо. Thank you, Anastasia Yurievna, for details review. Okay. The next step is discussion, dear colleagues. We proceed to the discussion of the dissertation.
Yeah, please, our temporary members, your opinion about thesis will be really important for making decision. If you will say some word about dissertation discussion and so on. Oh, also for future prospects, future study. Yeah, thank you. Please, Professor Veronica, Professor Javier, and Ilya, please tell something. Yeah.
Yeah, well, I think the thesis is correct. I mean, it's like going ahead with the complex determination of a group of compounds of very significant environmental concern. And I also agree that the determination in gas samples is not an easy task, right? And the difficulty of using microextraction approach to go ahead with this type of sampling and determination has a value. And also in the thesis, there is a progress in the difficulty of the approach, starting for headspace SPME in vials, then going ahead with higher bulbs for the sampling together with the portable GC and MPD detector. And then the last study with the high resolution mass spectrometry, in this case using a sorbenin tube. So I believe that there's a nice optimization development and also validation. So for sure the thesis has merit, novelty, and for sure interest. So I have only positive words for this thesis. For further works ahead, my suggestion, which has been commended also, is right now that you can use high resolution mass spectrometry, perhaps you can go ahead with also untargeted analysis, not only a targeted focus on several compounds, but perhaps why not untarget, looking for other, perhaps like derived products from these compounds that perhaps they are still present, or even when using these for cleaning soils and to test the contamination processes. Maybe with this untarget analysis, we can see more information. So, but this is just like a step further, like for ongoing works in the future for the group. But other than that, I have positive comments for this thesis. That's my opinion.
Yeah, thank you, Professor. Thank you. And I will also a little bit tell about regarding a candidate. Because actually I have worked in another laboratory, but know Bauyrzhan quite well. And what I want to also mention that he didn't include a lot of other publications he did, which is really in a good journal. Because he just included these 3 papers, which is related to his PhD thesis. But if you will check his profile, you will see a lot of another publications related to analytical chemistry. This is really great, and I all the time say that Bauyrzhan should defend much more or earlier than now, because he is ready really. And for today, I didn't notice any against. You know that here in Kazakhstan we have a criteria for evaluation thesis. It's about 5 or 6 like criteria, but I didn't find any criteria which is against he. So, but all is in line with this criteria. And what else? Yeah, as his supervisor mentioned, he's a really expert in not only this fuel components analytical determination, but he's expert in analytical chemistry. Yeah, using this GC and any all this equipment, mass spectrometer and so on. Yeah, so this is my opinion. And yeah, please also, if temporary members, if you will say some word, because please do not say how you will vote. This is a secret vote. So
Yeah.
thank you.
Yeah, that's my turn, maybe. Yeah, I completely agree with all the things said by Veronica. Yes, and from my side, I think that all the works carried out is valuable, of course, and it was well published. Maybe a major lack that I can see is the absence of multivariate optimization. So maybe in the future works, I will suggest to introduce some more robust and more comprehensive way of evaluation of variable evaluation. Using experimental design or Monte Carlo methods. There are different ways to do this. Another recommendation, in my opinion, is to try to move this field of research maybe on passive analysis, because passive analysis has many advantages, practical advantages. So if you are able to set a methods that is reliable enough and use passive sampling, that's a very big goal, since, as I understood, the sampling is in remote area, so remote areas are difficult to be reached, and maybe passive sampling is the right way to cope with this challenge. Maybe another points that I suggest for a more comprehensive evaluation from an environmental point of view is a more in-depth evaluation and control of weather conditions, meteorological conditions. And for instance, the humidity is generally a major problem when you deal with air and with analytes present in air, because can give competition or damage the surface of the sorbent. So sampling in air is quite complex. It's quite complex. It's a very big challenge and needs to be comprehensively evaluated. So this my last remarks points on the works.
Well, in my case, I have to say that I perfectly agree with both the comments of my colleagues, Veronica and Attilio. Apart from them, I would like to highlight the fact that, well, this thesis has three papers on the back that have been already evaluated also by external reviewers, which clearly demonstrate that this research deserves publication, and in fact it has been published. So this means that the results of the thesis are also valid for the scientific community, and that they have been already approved. And in our case, we are let's say somehow just refriending or approving that's the same thing. No, I think the topic is really of interest. I think the research group also has experience in the field. It's very well known for these types of studies from an international point of view, and they have tried to develop these analytical methodologies to solve a problem, local problem, regional problem, and there's where analytical chemistry should go. No, always to try to solve problems, and this is what we normally do. And I think the thesis has succeeded in this. No. We have also seen, we can clearly see an evolution in the papers from the first one to the last one. And we can see that the analytical procedure has been tackled, has been followed in total, from sampling to optimizing extraction conditions, then to detection. GC with different detection systems have already been used. The subject is complex, as my colleague Veronica said, and also Attilio, is very complex. Sampling, real sampling, and developing these types of studies is really complex, and that fact should be taken into account. That should be highly valued. No, and I would like to also highlight the fact that the candidate has answered the questions very well. He has been given great effort to trying to defend the thesis in English, which is not easy, in front of also of foreigners like us, like external reviewers. So this is not easy, and I would also like to highlight this this fact now, that defending a thesis in English like this is also of very high importance nowadays. So that is my general comment. I don't know if it's the time also, but I would like to thank personally the invitation to be here. I know that my colleagues, also Veronica and Attilio, are also
Yes.
very thankful for being here
Yes.
as external members. So thank you very much. Thank you to the university. for the kind invitation. It's great that our colleagues from around the world call us to do this very important task. So I'm sure that all of us are really thankful for this opportunity.
Thank you, Professor. Okay, the next step, a break is announced for the secret ballot.
Yeah, dear colleagues, just a moment. We need to we need to move to another hall, the other participants, and then we can vote. Yeah, just a few minutes. Что-то должно быть.
Recording in progress.
So, dear colleagues, do you hear me? Так, по-моему, все, да, здесь? Так, раз, два, три, четыре, пять, шесть. 8, да, должно быть. Так, где здесь надо было еще раз? Что-то я уже... Вопросы? Вопросы, вопросы. Дополнительно, да, скорее всего. Вопросы. So, dear colleagues, you will find now in your screen, please choose one, only one option, okay? Okay, now it's ready, and I will just каких всех принять здесь, да? Принять сюда.
Recording in progress.
Все. Что-то как-то...
Okay, dear colleagues, I ask the members of the dissertation council to approve the voting protocol. Yes. Based on the defense and results of the secret online voting, the dissertation council at Al-Farabi Kazno awards the degree to award the degree of Doctor of Philosophy, PhD, Bukenov Bauyrzhan Omerbekovich for the dissertation on the topic development of analytical methods for determination of unsymmetrical dimethyl hydrazine transformation products on A specialty ATD 05301 chemistry. Our congratulations to Bauyrzhan, and thank you all for participating in the defense. Наши поздравления, Булат Нурланович, Дмитрий Косяков как руководителем Bauyrzhan,
Thank you very much.
научной группе за поддержку. Final words, please, Bauyrzhan.
Thank you very much for your decision. So I would like to thank the dissertation council, the temporary members of the dissertation council for this, and also reviewers, my colleagues, my friends, and my family for their constant support and help during my research and my studies. Thank you very much.
Okay, thank you for all.
Okay, thank you. Good night, guys. Bye.
Thank you, bye-bye.
Thank you
Bye.
and congratulations. Congratulations.
Yes.
Congratulations.
Thank you. Congratulations. Bye bye.
Bye.